Okay, so picking up where we left off yesterday, we talked about graphs of polynomials, okay? So with the graphs of polynomials, we talked about the importance of factoring and what the factors mean, okay? So in terms of factors, what happens is that you have your single root, double root, triple root, and everything else can be multiples or added on after that, right? So either it's a number after one, like 1 plus 1. Every number comes from 1, 2, and 3, pretty much. So we're going to be using this information to graph. Key thing that we're going to focus on is finding your factors, creating the graphs, okay? So here we go. Up here. Where's that? On the back of your notes from yesterday? All right, so here we have the graph, the function f of x equals x times x minus 1 times x plus 4, okay? What we're going to do is identify, without expanding, what the degree is, based on the degree being odd or even, what its potential shape could be. So we're determining its beginning and end behaviors, okay? So looking here, our zeros would be x equals 0, because I have x right here, right? We have x minus 1 equals 0, so therefore x equals 1. And we have x plus 4 equals 0, therefore x equals negative 4. Okay? So my zeros would be 0, positive 1. I'm going to make this 1. 1, 2, 3, 4. And negative 4. Questions on identifying your zeros? Yesterday's. Okay. So then here, as far as the degree, if I was to multiply x times x times x, it's going to result in x cubed. So this is a third degree polynomial. And it's a positive third degree polynomial because my leading coefficient is positive 1, which tells me that my function has to end positively. And with odd functions, we said that they're opposites of each other, right? So if my end behavior is positive, that means my beginning behavior had to be negative. So my graph is going to start negative, but end positive. That's the situation that's taking place, okay? So through this, we don't care what the y values are. We're just drawing a sketch of the graph right now, okay? So we're going to start negative, and I'm going to do whatever I have to do to get through all of the points. And there is my sketch. Good job. The line looks a little shaky. It's a little bit. It's not perfect, but so we found our x's, determined the degree, determined the sign of our coefficient, and created our sketch. Okay, let's try it again. On 14, is it in factored form? No, it is not factored. So because it's not in factored form, before I do anything, I need to factor it. The number one thing you want to check for when you're factoring is there a GCF? Is there a GCF here? Yeah, what is it? Greatest common factor. It's x. I can divide every term by x. When I divide every term by x, I get x parentheses x squared minus 4x plus 4. Sure. You're right. Okay, is that fully factored? If you said no, it's not. So I have to ask myself what multiplies to give me 4 but adds to give me negative 4. So what multiplies to give me 4 but adds to give me negative 4? Negative 2 and negative 2. So that's x minus 2 times x minus 2. So my factor of this polynomial is x times x minus 2 squared. Questions about factoring? Okay, now we're going to identify our zeros. So my 0 based on the x is at 0. My 0 based on x minus 2 is at 2, positive 2. Okay, positive 2 is unique because it has a power of 2. Yesterday we talked about double roots. What happens at a double root? Yeah, what happens with a multiplicity of 2? What happens? Let's look at it. We talked about yesterday with a multiplicity of 2. What happens? We said it does what? It just touches it. It does not cross that point. It touches. So it's okay. So when I have a multiplicity of 2, it's going to touch. Okay. So we were at note. I'm going to put a little asterisk, remind myself, you're special. Okay. All right. So the degree here, what's the degree? Say third degree, and it is positive. So I'm going to end positive, which means I have to start negative. Got it? So if I end positive, I have to start negative. So my goal is to make sure I go through 0 and I touch at 2, right? I don't go through 2, I touch. So I'm going to go, mew.
I thought that was funny.
Thanks.
It was like a cat.
That's all they do.
Yeah, can I pass that?
Only this is class based off of compliments.
I would have been passed.
All right. Do we see the difference between a single and a double root?
Yes.
Okay. All right.
Oh God, it's getting real.
No, you're doing 16 on your own.
Oh.
Okay. 15. All right. 15. Now we have a negative quartic, right? A negative quartic. How do I know that?
Negative.
The negative sign and the 4. So we have a 4th degree polynomial. Okay. With 4th degree polynomials, they're going to end positive and mid with a 4th degree, but the end is how they also start. In this case, it's a negative. So if we're ending negative, we also have to start negative. Does that make sense? Okay. So if we end negative based on our leading coefficient, we also have to start negatively. All right. Before I do anything, what do I have to do? What's the GCF here? X to the what?
To the second. Third.
To the third. My GCF is negative x to the third. So when I factor out negative x to the third, I'm going to get negative x to the third times x plus 3. When your leading coefficient is negative, your GCF is negative. Got it? When your leading coefficient is negative, your GCF is negative. All right, so my zeros are where? Where are my zeros at? And 0 and negative 3. So we have a 0 and we're at negative 3. Okay, so yesterday we talked about our power functions and we said that as the exponents get bigger, as the powers got larger for the even, what happened instead of a more curved, it starts to do what? It's going to do a little flattening, right? It's going to flatten a little. So when we look here and we graph, we have to go through negative 3 and we have to go through 0. And that's because they have odd multiplicities, right? If I have a single multiplicity and a, what's that number? 3, a multiplicity of 3, I have to go through. Odd numbers, you go through them. Even powers, you're going to go to, you're going to touch them. So I'm going to go through. It's not going to be as curved as a quadratic. Pretend that's pretty straight, but that means you can't pretend. That's what this means. Thanks for the support. Okay, it's almost a quadratic, but not because it has a flattening. All right, 16. So 16, you're going to do it from start to finish. You're going to factor. You're going to identify how it starts and ends and attempt to draw a sketch. If you're not confident, use a pencil. All right, so our GCF was x squared. So when you factor out the GCF, I'm gonna do it at, I can do it on top of it. There you go.
That's where I messed up.
X squared. My pen does not want me to write. It's like, no, you can't write. Let's try that again. X squared, there we go. And we're left with x squared minus x minus 20. Okay? Shh, guys. Is that fully factored?
No.
No, how can I fully factor that?
Negative 5 and 4.
Negative 5 and 4. What multiplies to give me negative 20, but adds to give me positive 1, it would be negative 5 and positive 4. All right, so this lets me know I have a 0 root, I have 5 as a root, and I have negative 4 as a root. Do we see that? So we're at negative 4, 0, 5. Okay, 0 is a special root. It's going to be a double root. So instead of crossing 0, I'm going to have to do what? I'm going to touch it. Okay, I have a positive 4th degree polynomial. That means that if I end positively, I also have to start positively. So I'm going to start at positive y's. I'm going to work my way to 0. At 0, it touches. And then it's going to come back up.
I was just gonna say it. Where's the mommy?
I can't stand y'all. All right. And so that's what happens with the double. Okay. And again, when we're sketching, we're just making sure that we understand the shape, understand our roots. Okay. Understanding the shape, understanding the roots. Got it?
Got it.
All right. Okay. So that's not where I wanted to go. So we're going to pause for a moment. Here we go. I'm going to give you a few minutes based on what we did. You're going to match the graph. All you're due now? I don't know. Check with your peers. All right. So you have 10, 11, 12, 13, 14, and 15 left to do. And you have 6 functions and 6 graphs. And you're going to match them to which ones they are. Using your properties. They're really, there's a lot of force. Oh, I don't know. Okay. And then I guess this will be, what time is it? What time do we get out of here? Okay. You should be able to finish this for class. I'm not.